Good. Today is the 24th of September, 2019, Math 1, and we're going to talk about the ticket to ride. It's actually, we're talking about, no, I'm not. It is, but it's, here, let me start with a different question. It's starting with why negative exponents work. Don't worry about changing your title. So here's the deal. Learning goal. Trent.
I can use the graphs of functions to describe real life situations.
The why, Micah.
Graphs are all around me in the world. I want to be able to understand and create them.
Cool. On March 11, 2011, a tsunami triggered by an earthquake destroyed the Fukushima nuclear reactors in Japan. You may know about that. The radiation was released and is still being released. The radiation that was released and is still being released will slowly decay over time and become less and less harmful. That decay is modeled using a decay function. Exponential growth and decay functions use exponents. To fully appreciate these functions, you have to understand exponents and how they work, including negative exponents. So by the end of this lesson, you're going to be able to do like 2 raised to the negative 2 power. That's what I'm trying to get you into. And we're doing this so that tomorrow we can start graphing things that would relate to radioactive decay. We're trying to get into exponential functions. So let's start with slide number 6, I think. So we're going to start with slide number 7. I'm not on that, so I'm on a different presentation. Don't worry about it, just copy this right now. So I have 2 to the third. 2 to the third. What does that even mean? Chris, don't give me the answer, tell me what it means. Which equals? Beautiful. Good job, Chris. Jordan, 2 to the second.
Is 2 times 2.
Which equals?
4.
Beautiful. Aiden, 2 to the first, which equals? 2. Beautiful. 2 to the 0, which equals? Yes, Jackson. 1, because we already learned about that guy. We did this one earlier. When we were, why did you do that? There must have been some function that you had to raise it to a 0 power. I don't know. Now, 2 to the negative 1 equals, and don't go to the next slides yet. You think you've got this?
Probably not, but yes.
I like that. Probably not, but yes, go for it.
Negative, or 2 times negative 2.
So negative 4. That is not correct, but I appreciate your willingness to be wrong. JJ.
Would it be negative 1?
It is not negative 1. Miranda. It is not negative 2. Gavin.
Positive 2.
It's not positive 2. Jordan.
0.
It is not 0. Maddie, go for it.
Is it 4?
It is not 4. Bradley.
0.5.
It is 0.5, although I'm going to write it as a 1/2.
I was going to say 3.
Okay, ready? What is 8 divided by 2?
4.
What is 4 divided by 2?
2.
What is 2 divided by 2?
1.
What is 1 divided by 2?
1/2.
So if it was negative 2, it would be 1/4.
Yeah.
Yep, negative 2 would be 1/4. Why? Because what is 1/2 divided by 2, which means cut in half? What is 1/2 cut in half?
Because you made it into
1/4. This is why negative exponents work. Now I'm going to just teach you the little tricks on how to make it, how to do this thing. So yes.
Are we ever going to get like to the negative 3 power?
Sure. Negative 3 would be 1/8.
Oh, okay.
Yes.
Are there going to be like any crazy ones, like to the negative?
You can do anything to any power because it's just
8.9.
a 0.9 power. No, you're going. All your powers are going to be integers. There are ways to do this one. You don't need to know it. 4 to the 1/2 power. Not this lesson though. Crazy, isn't it? And the answer to that one is 2. But not part of this lesson, not part of this lesson. This is part of the lesson though. We're gonna go to Ticket to Ride. And I'm going to read this because I haven't read it lately, Gavin. Why do you need to learn about negative exponents? Negative exponents are one of those math tools that you'll need in future math classes, yes. Plus, we need it for exponential growth and decay functions, which we're doing tomorrow. Some of the applications are converging series, limits, scientific notation, taking derivatives. It is like knowing how to use a turn signal on a car. Alone, a turn signal is kind of useless, but once you start driving, you will need to know how to use it. Okay, yeah. Got it, I get it. You will need negative exponents once you start using the big math that runs the world. By the end of this lesson, you're going to be able to handle these negative exponents. Okay. Whatever. This is going. All right, so first off, welcome to the math house. This is the math house. Everything in the math house is 2 stories. There are no single-story math houses. Everything is 2-story. Are there any ranch houses? No, because a ranch is a single story. Everything is 2-story. Are there split levels? No. Are there mobile homes? No. Everything, unless it's a 2-story mobile home, which do exist, I guess. So everything is 2-story. Look, here comes the number 3/5. And it walks into the math house. 3/5. You got it so far? Here comes the number 1/2. Goes into the math house. 1/2. Yes?
Yeah.
You're with me, Jordan. You're confused.
I understand it.
Here's number 7. Number 7 goes in the math house and becomes 7/1. Now here's what negatives are. Negatives are tickets to ride the math elevator. I need 3 people. First 3 people get up and sit in a chair.
I thought you meant our chairs. I was like, okay.
There's another chair. It's been saved.
We're special. We're the people in the chairs.
Hit it on the edge of the seat.
Like Spider-Man, I'm the guy in the chair.
Poor JJ wanted to come up here so
I thought you meant
bad.
our chairs. I was
You went.
okay.
Maddie, what's your first name?
Maddie.
Good job. Maddie to the -2 power.
Okay.
Stand up on top of the chair.
Oh.
How old are you?
I'm 13.
30. Dang.
Wow, we got a long way.
13 raised to the 3rd power. Hello.
Hello.
H raised to the -1 power. Hello.
Oh. I was like,
Here's how it works. Are you on the top floor or the bottom floor of the math house?
That's a good question.
Let's see. Are you on the top floor or the bottom?
Yes, I'm on the top floor.
Where are you?
bottom.
Where are you?
Oh, bottom.
Got it. Notice if you have a negative exponent, the negative itself is a ticket to ride the math elevator. It either takes you up or down, depending on where you're at. I have a question. Do you have a ticket?
Yeah.
He has a ticket. Get on the elevator and ride up. Goodbye, ticket. He used up his ticket because he rode the elevator. Hello. Do you have a ticket?
No, I do not.
Notice, she does not have a ticket. But watch this. I'm going to give her a ticket.
Bum, bum, bum. Wait, does it have? How does it?
I'm in charge of the tickets. I can do whatever I
I was
want.
like, wait.
Oh.
Do you have a ticket now?
Yeah.
Use your ticket. She goes down and
No.
erase your ticket. Her ticket is gone. Do you have a ticket?
Yeah.
Where do you get to go?
Up.
Go up.
It's brand new white.
Okay.
Can you erase your ticket? This is how it works. If you see a ticket, you either go up or down. Ready?
So tall.
Where do you get to go? Where do you get to go? Where do you get to go? Get rid of your tickets. Get rid of your tickets. You used them up. Look at that. You're really good at this game. Where do you go? Where do you go? Where do you go?
I'm gonna fall getting up on this chair.
Look how fast they're erasing their tickets. Go.
Wait.
You have to erase your ticket.
What's that? What's that? It doesn't matter. If he's up, where's the only place he can go, right?
Yeah.
So where's he gonna go? Down. Where are you gonna go? Down. When I give her a ticket, where's she gonna go? Up. So tickets move you up or down. Give them a nice little golf clap for participating.
We're so cool.
Can you put the whiteboards back in the whiteboard box?
That was pretty great.
In your notes.
Down.
3 to the -2. This is a ticket. To ride the elevator. What floor is 3 to the -2 currently on?
The bottom floor.
No.
Oh.
He's on the top floor. Where is he going to go?
Bottom floor.
It becomes 3 to the 2nd. What's on the top floor? A 1. There's always a 1 on the top and the bottom floor. Sometimes if they're not there, they become visible.
They're invisible.
How about this? 1/5 to the -2. Do you see the ticket?
Yes.
Where does he want to go? All negatives do are move things up and down, up and down. Questions? Everyone's about to have to talk to me. Everybody. Including you.
I always talk to you.
Oh,
What do
that's
you
true.
mean?
Including JJ. Okay. Questions? Yes, Trent?
Oh, so where the negative exponent is, that's what floor they're on.
Ask me again.
If the negative exponent is on like the bottom of the fraction right at the top, that means what floor they're on.
I'm missing the last couple words.
So if the negative's like on the 1, let's say if you move it to the 1, that'd be on the top floor. There, I think
Okay, I'm not sure. So this guy, the ticket is right here. This piece is going to go up.
Yeah.
The ticket is right there. That piece is going to go down. Go through this and see if it starts clicking. We're going to do a whole bunch of examples right now. Look, wait for the examples. Here we go. We're going to start over here with Jackson. Jackson, who has a ticket? The X. Where's the X going to go?
Down.
Down. And what's going to be left on top?
The 5.
Does the 5 have a ticket?
Oh, no, the 3.
So what's going to happen here is this X to the -3 is going to go down to the bottom. The ticket's going to go away. And what's left on top? A 1. The 5 isn't on top. The 5's on the bottom. 1. Good job.
I was pretty right.
So would it be 5 to the -3?
Wait, would it be
So
5x?
this would be,
So
okay, draw the house. There's the house. Does the 5 have a ticket?
No.
Where is he currently?
On the bottom.
So where's he going to be over here? Does the X to the -3, is there a ticket there?
Yes.
So where's this going to go? Where'd the ticket go? It got used. What's on top?
1.
The 5's not going to disappear. The 5's.
Oh, sorry.
Let's try another one.
Wrong.
Okay, Lizette. Does the X have a ticket? So is it going to go anywhere? Does the Y have a ticket? Where's it going to go? It's going to go to the top. Done. What's left on the bottom?
1.
1.
It would be X.
How would I write this out?
X, Y.
I'd write it X squared, Y squared.
Just right next to each other.
Wait, but
So X, Y.
X squared, Y squared.
you can't combine X with
We've got a lot of examples. You're going to catch it. Let's go to Maddie. Does the X have a ticket? Does the Y have a ticket?
Yeah. No.
No.
Oh, no, because it doesn't have an exponent.
This is not a ticket, this is just a negative. Does anybody get to move? No. Chris, does the 2 have a ticket?
No.
No. Does the 2 get to move?
No.
Does the X have a ticket?
No. Wait, yes.
That's a ticket. So where's the X gonna go?
Yeah.
Down. Does the Y have a ticket? So what's the Y do? Your options are up, down, or stay.
Okay.
There we go. Mr. Fisher,
Yes, sir.
tell me what the X is gonna go, dude.
He's gonna move down.
Down. Good. Micah, tell me about the Y.
It's gonna go.
There you go.
And
So
then,
it'd be,
can we call it if they stay in space, they're
We're just gonna call it stay.
home
so it'd be
alone?
y over the
Home
second
alone.
power to
Because they're all lonely.
So just flip. It's gonna be Y to the second over X to the third. They just move places. Ah, Gavin, tell me about the Y.
It's the one. Oh,
The one, excuse me.
It stays.
Stays. Taryn, where does it move to? Up. So you're just gonna give me up, down, or stay. The Y is gonna go up. Ooh, Presley.
What?
It stays?
But doesn't have a ticket?
there has to be always one
I
to
know.
How about now?
Oh, it's gonna move down.
It's gonna move down, and what's gonna be on top then?
the
A 1. If there's nothing there, it's a 1. There's always a 1 floating around. Even if you don't see it, it's there. All right, Jordan, tell me about the Y.
Okay, so the Y is an X.
Just tell me the Y.
Y is gonna. Sorry, the Y is gonna stay.
Okay, the Y is going to stay. Tell
Wait, no,
me,
the Y is gonna
does the Y have a negative exponent?
I was right the first time.
Let's just keep going.
Okay.
Does the Y have a negative exponent?
No.
So what's the Y going to do?
It's gonna stay.
What's the X going to do?
Go down.
What's the 2 going to do?
Stay.
There you go.
I was right.
Bradley,
the first time.
what's the X going to do?
go down.
Nico, what's the Y going to do?
Go down.
There you go. JJ, what's the X going to do?
Stay.
And what's the Y going to do?
Go down.
Nice. Trent, what's the 2 going to do?
Stay.
What's the X going to do?
Go down.
Miranda, what's the Y going to do? What's the Z going to do? Greenlee, what's the 4 going to do?
Stay.
What's the X going to do?
Go down.
Perfect. This one, back to Maddie.
Wait, Gavin. So.
Oh, Gavin, sorry, back to Gavin.
Uh,
Gavin, what's the 4 going to do?
Stay.
What's the X going to do?
Stay.
What's the Y going to do?
Go down.
Maddie, what's the 2 going to do?
the 2 goes down.
What's the 5 going to do?
It goes up.
Chris, what's the 4 going to do?
4. Wait, I got down to 1 under, so 4 is gonna stay.
What's the X going to do?
Stay.
What's the Y gonna do?
Stay.
Got it. Lizeth, what's the 12 going to do? What's the Y going to do? Jackson, what's the X going to do?
Stay.
This one, okay. Hey, Aiden,
There.
what's the 2X going to do?
Stay. Wait. Down.
It's going to go down. What's the Y going to do?
Okay.
Notice, this entire blob is going to go down. This 2X, the entire 2X is going to go down, and it's going to lose its ticket.
Can we call that a couch cushion?
What are these names?
All right. Taryn, what's the negative 4 going to do? Micah, what's the 5 going to do? Gavin, what's the negative 4 going to do?
Stay.
What's the X going to do?
Go down.
What's the 2 going to do?
Stay.
What's the Y going to do?
Go up.
Jordan, what's the 16 going to do?
It's gonna go down.
The 16 does not have a
No, the
ticket.
16. It's gonna stay.
What's the X going to do?
Go down.
What's the Y going to do?
Go down.
What's the Z going to do?
Stay.
I'm going to give you another one here. What do you think the 1's going to do?
One's gonna go in.
Go down.
1's going to go down. What's the 3 going to do?
Go up.
This just flips it over. This is a ticket that technically does this. It goes 1 over 1/3,
Field ticket.
like that. it's taking the entire thing down, and when you evaluate it, it actually flips itself up over. This is 1 divided by 1/3, keep, change, flip, which becomes. So when I see this, it's just flipping the fraction over.
So the final answer would be 3/1.
Yeah, the final answer would be 9.
3 divided by 1.
No, because it's 3 squared
Oh.
because of the square. You have IXL to do for homework. If you get the IXL to 100, I'm going to put another one up here for you to work on. It's not homework, but if you get this IXL to 100, I'm going to give you something else to work on also.
Is it V3?
It's whatever's posted.
It's
Says
V3.
algebra. V3.
Nobody's listening to you. Huh? You were what? I was like.
Sorry.
No.
Stop now.
No, you didn't do anything. Huh?
Four. Don't even come at me. Yeah. What?
Which one are you working on right now? B?
V3.
If you get this to 100 in class, you can work on B1. If you don't get to 100 in class, you keep working on it. You have plenty of time to get this done in class today. That is it. Thanks for watching.